Welcome to class of physics. So now in this class, I'm going to explain last two steps of the derivations of elastic collisions, which one already derived in the previous video. So then I'm going to discuss the three special cases. Okay. Let's first see how to simplify or how to obtain last two steps, that is the final velocities after the collisions. Okay, so here is the derivation. Now, our aim is to find the value of velocities after the collisions. So that is v1 and v2 we have to find. For that, the final equation should be in terms of all known quantities except v1 and v2. So that up to equation 5 we have derived. So what is equation 5? Equation 5 is here. v2 equal to v1 plus u1 minus u2 and v1 equal to v2 minus u1 plus u2. Here these equations are not sufficient because in this equation there is a v1 term. This is also unknown term. For that we can't find both these unknowns at a time. For that we have to modify these equations in terms of all known quantities. For this equation 3 I am going to use by substituting the value of v2 one equation and value of v1 from another equation in equation number 3. Okay, so here is the equation 3. So now I am going to write equation 3 here. What is equation 3? Equation 3 is m1 into u1 minus v1 is equal to m2 v2 minus u2. Okay. Now I have to find the value of v1 by substituting the value of v2 from that equations. So what is v2? v2 is equal to v1 plus u1 minus u2, okay, from this equation. So now substitute and simplify. I am going to substitute the value of v2 in these equations. Here we have to replace this v2 by substituting this value. Then this becomes m1 into u1 minus v1 is equal to m2 into v1 plus u1 minus u2 minus of u2. Okay. Now simplify. It becomes m1 u1 minus m1 v1 is equal to m2 v1 plus m2 u1. Okay, so minus of u2 is minus of 2 u2 into m2, then this becomes minus of 2 m2 u2. Okay, so now bring this m1 v1 into right hand side and okay, so here it is m1 v1, bring here, and the remaining these two terms into left hand side. Then this equation becomes m1 u1, here this is plus of m2 u1, then that becomes minus of m2 u1, then minus of 2 m2 u2 is there, it becomes plus of 2 m2 u2. So this is equal to m2 v1, okay, this one, and this minus of m1 here when you take into right hand side it becomes plus of m1 v1. Okay, so here from these two terms u1 is common, take common, then it becomes m1 minus m2 into u1 plus 2 m2 u2. This is equal to, so from these two terms v1 is common, then it is m1 plus m2 into v1. Okay, then we have to find the value of v1. For that write v1 and the remaining term into another side, then it becomes m1 minus m2 into u1 plus 2 m2 u2, okay, divided by whatever the multiple is there. So when you take into another side it becomes divided by, then it is m1 plus m2. Okay. So this one we can write it as v1 is equal to m1 minus m2 into u1 divided by m1 plus m2. So here plus of 2 m2 divided by m1 plus m2 into u2. Okay, now we get the value of v1. Okay, so here m1 minus m2, so here what is m1? Mass of one object, and this is also mass of another object. u1 is velocity before collision of that first object, and here m2 is same mass of second object, and u2 is velocity of second object before collision. For that, these all are the known quantities at one side, then you can easily find the value of v1. Okay. Similarly, now use this another equation, substitute in equation 3, then you will get the value of v2. Okay. So here I am using equation 3 again. What is equation 3? It is m1 into u2, sorry, m1 multiple of u1 minus v1 is equal to m2 of v2 minus u2. Okay. Now here we have to substitute the value of v1. What is v1? So here v1 is equal to v2 minus u1 plus u2. Substitute here in place of v1. Where is v1? v1 is here. Okay. For that, m1 into u1 minus of v2 minus of u1, sorry, here it is, okay, minus of u1 plus of u2 is equal to m2 into v2 minus m2 into u2. Okay. So now you can write this as m1 u1 minus here minus of m1 v2, then minus plus of m1 u1, and then minus plus minus of m1 u2 is equal to m2 v2 minus m2 u2. Now m1 u1 one term, and here also m1 u1 is there, then it becomes 2 m1 u1, and then here m1 v2 is there, here also m2 v2 is there. Now bring this into right hand side, okay, and this into left hand side, then it becomes 2 m1 u1. When you bring this into left hand side, this is minus is there initially, it becomes plus of m2 u2, and then here minus of m1 u2, and now take this into right hand side, then it becomes plus equal to m2 v2 plus m1 v2. Okay. So from these two equations, u2 is common. For that, we can write m1 u1 plus of m2 minus m1 into u2 is equal to, from these two equations v2 is common. For that, it becomes m1 plus m2 into v2. We have to find the value of v2. For that, bring v2 one side and remaining to another side. So v2 is equal to 2 m1 u1 plus of m2 minus m1 into u2 divided by m1 plus m2. Okay, v2 is equal to, can write this as 2 m1 u1 divided by m1 plus m2 plus of m2 minus m1 divided by m1 plus m2 into u2. Okay, so this is the final equation to find the value of v2. Here m1 u1 and m2 are known terms, you can easily find the value of v2. Okay, so that is the equation number 7 and equation number 6. Okay. Special cases are here. So two equations are already obtained. These two are the two equations. Now using these two equations, I am going to import some special cases or conditions. So one is, if both the masses are same, m1 equal to m2, okay, then what happens? When you take m1 equal to m2, the equation 6 and 7 becomes, okay, so that's here p1 equal to m1 equal to m2, so that is equal to, take it as m. Okay. That means wherever m1 m2 is there, replace by m. Okay, m minus m divided by m plus m into u1 plus 2 m by m plus m into u2. So m minus m is 0, so it is 0. That means this whole term vanishes. Here it is m plus m is 2m, 2m get cancelled. What is remaining? p1 equal to u2. So similarly, when you substitute the value of m1 equal to m2 equal to m equation 7, then equation 7 becomes p2 equal to u1. What is p1? p1 is velocity of the first object of mass m1 after the collision, so that is equal to u2. That means the velocity of one object is going to transfer to another object. Okay, so here also same. Okay, and then if one is at rest, okay, take m2 as rest 0, sorry, that m2 object having velocity u2 is 0. That means substitute the v2 value is 0. When you substitute u2 is 0 here, then this whole term becomes 0. The remaining is m1 minus m2 by m1 plus m2 into u1. Again, if you impose the condition m1 equal to m2, then what happens? This equation becomes v1 is equal to u1. Similarly, v2 equal to what? It is so u. That means just the velocities again, those are transferred one body to another body. And equation 3 is, that is the third case, is m2 is heavier than m1. Okay, m2 is heavier than m1. So in that conditions, already this m2 is at rest, u2 is equal to 0. So in these conditions, what happens? v1 equal to minus u1. That means the velocity of the first object which is moving, just it is going to change its direction. It is going to bounce back with the same velocity which is having already. Okay, so but the v2 is 0. The initial before collision and after collision, the velocity of the second object is 0. Next class, let's going to discuss a important concept, that is the collision in two dimensions. Okay? Thank you.